All right, it's great to be here. I'm here to tell you guys how to decentralize your front end for this hackathon and potentially beyond. And we're going to talk about how to do it with a tech stack that we're calling the blockchain operating system. So just to kick it off, what is the blockchain operating system? So two main things. One, it's this common layer for discovering open web experiences that's compatible with any blockchain, which is a part of it that we're really excited about. And then maybe even more directly for those of you who are developers in the room, probably most of you, it's a tech stack for building fully decentralized applications. And most importantly for this talk, it's about decentralizing your front end. So the main reason we decided to build BOS is to solve a few different problems. So onboarding and distribution are common ones. Compliance is one that's becoming a lot more important, especially if you're building financial applications. Complexity, another one for developers. There's a lot that comes with building a front end these days, and we aim to make it easier. And then we're really excited about bringing cross-platform support to this ecosystem and really just, letting blockchains collaborate in a more compelling way. So the BOS stack is a few different pieces. We'll mainly be talking about user interfaces and blockchains today, but we also do have some products for onboarding, mostly around users being able to use blockchains without actually needing an explicit wallet. If they're new to their crypto journey or using a crypto application, they may not have a wallet. And they may not want one just yet. And we do have some products for that, but less relevant to this talk. And here's kind of a snapshot of a few of the different pieces that fit into the BOS stack. Again, we have what's called these gateways, which are going to be basically interfaces that enable users to interact with the front ends of various decentralized applications, like, say, Aave, Uniswap, Liquidity, and others. And the code for these will be stored both on the Near blockchain for the front end and then on, say, the Ethereum blockchain for the smart contracts. So one of the biggest things we aim to solve when we set out in building the blockchain operating system is that typically developers are forced to make a choice between distribution and decentralization when it comes to their front end. You're way better off kind of baking your front end into a few existing applications or even hosting your own front end and promoting the hell out of it if you're trying to get distribution. If you want decentralization, though, those are kind of counter to the things that you want. Fortunately, we think we have a way to kind of thread the needle and actually give you both increased distribution while also giving you even more decentralization you would have had if you're hosting your own website on Vercel or something like that. So to make it very clear in exactly how it works, let's imagine that you guys are developers, and first you're going to deploy a smart contract to Ethereum, and now you need somewhere to deploy your front end. And let's say you choose BOS and you choose the Near blockchain. So what you're going to be doing today is you'll actually be deploying basically React's JSX code, these components. You'll make a component for your dApp that you will deploy to the Near blockchain, and then users will be able to interact, access that interface, conduct some actions that will then result in a transaction, and then they can send that transaction to Ethereum, which means they can have basically they're interacting with two different blockchains in one experience. They don't necessarily know that. All they care about is accomplishing their goals. And a component of this we're really excited about is that since you will be able to deploy your code on chain, what this means is that DAOs that are currently managing their smart contracts can now also manage their front end all on chain. So we're hoping we can see a world where every single DAO will do this. If you have smart contracts, you will at least have some basic user interface or even a very full feature user interface that you as a DAO will maintain and upgrade that reflects the usage of your smart contracts. To make this a little bit clearer, we'll talk about it from the user angle. So let's imagine that we have a user. The first step to use BOS, they're going to navigate to some kind of interface or front end. This could be MetaMask. This could be Zapper on iOS. It could be near.org. Soon it's going to be Urbit, which we're pretty excited about. And it could also be this site called BOSVG. That's basically a doc site that we have. So by going to any of these, they can access all of the same applications. So then they're going to select a dApp that they want to use. These are 4 examples we have available today: Aave, 1inch, Uniswap, or Liquidity. Let's say they select Aave. So after they select Aave, then the Aave front-end code is going to be loaded from the Near blockchain. So there'll be an RPC request to the Near blockchain, which will then return the JSX, and that JSX will be rendered in a specialized virtual machine that'll be running on one of those different gateways that the user first navigated to. And this virtual machine is designed to basically be a strict subset of JavaScript that has some extra security guarantees, so that, if it is near.org, and there's private keys in local storage for some reason, those are not able to be snooped easily. That's the goal. So then, they've loaded the front end, they're doing their thing. They're like, I want to deposit 100 USDC into Aave. Great. Forms a transaction because like they're just using a front end. And then it hits the Ethereum RPC, sends the transaction to Ethereum. They then get like, some kind of receipt showing them that the transaction was mined, get a message saying that they were deposited, it updates the front end. Now they're happy and they've used a fully decentralized or cross-platform application. What's really cool if you want to get really paranoid with this, which we like to do, is that gateway in the first step can be self-hosted. And it can be self-hosted very easily. You can run this in an Electron app and soon we'll have that as an access point. Or I think even more commonly, we'll just see people using their typical mobile wallet and they'll be able to access the application, kind of skipping DNS entirely, skipping going to this front end entirely, just interacting with 2 blockchains at most. 1 blockchain if it's fully built on Near, or 2 blockchains if the front end's on Near and then the back end's on Ethereum or an L2 or Solana or whatever it may be. And the best part for you guys is that it's super easy to get started. So it's basically 5 steps if you guys want to build with this today or even get some things running. You can go to near.org. You can use the search function to search for these 5 different applications. You can click fork. You can make changes, and then you click save. And that save is actually going to be a transaction to the Near blockchain. It's super cheap, should be a few cents. If anyone in here needs some Near, come talk to us at the Near booth. We'll get you guys some Near, and you'll be on your way. And then the other aspect of this that we're really excited about is that every single component that you build can be composed with other components. The same way if you're familiar with React, where you can have higher order components and you can compose components, you can pass state and props between them. You can do that with BOS with a bunch of different components. Like there can be 10 different components that are deployed. I gave an example of a page for Polygon that shows like a few of their different applications, all of which are available on BOS. And then it shows an interactive swap component there that's also being rendered in the same page. And this is actually going to be like 7 different components, all of which are composed together into a single experience, which is really cool. So now on to the fun part, which is the demo. And we'll actually walk through how you can access BOS components and how you guys can get started for this hackathon. So this is actually a demo that was created for ETHSol. And I think what's fun is it's going to be a very easy way for us to show how you can get started. So in this demo, there's basically 4 different components that are going to be showed. You see that little widget line? That's basically a different component that's being loaded into this higher order component. So some of the things you're going to get out of the box here is like detecting the network that the user is on. That's going to be like the first thing that this component is doing. Then you can detect like basically who the sender is going to be from state. And we have some examples of how to do that. You can load their balance, their ETH balance, and you can load their staked ETH balance. Because in this case, where this is like a Lido component example, like helping people stake their Ethereum. And I think it'll be even easier if we actually just go to this and show you what's happening. So here you can actually see this being rendered. This is the Lido component. And I can go up here and I can click fork. Now we're seeing the code. So users can actually do this. They can view the source code in the browser, same way you'd be viewing the source code for like a smart contract on Etherscan. So they can check out, I can't actually see it on my screen. Bear with me. Somewhere in here, we'd be able to see the smart contract, but I cannot actually see it. Maybe let's just go to the actual Lido contract. Let's see here. Here we go. So let's fork this one. Here you can see the smart contract. So like a savvy user would be able to actually check the smart contract, go cross-check it on another website and be like, cool, I am very confident that this is going to actually send my ETH to the contract I want to, which in this case is the Lido contract. And you can easily change that to, say, the Lido contract for Polygon. And then I can just click save. And it's actually just going to show me the state diff. So this is like showing you like the code that's actually going to be saved to the Near blockchain. Click save data. I'll probably have to sign a Near transaction maybe. Oh, I don't even have to. Yeah, if it's below a certain size, then you don't even necessarily have to save it do a transaction in order to save the state diff. And then bam, we're good to go. And I can preview this. I can preview it here so that I can actually see what I'm doing and then just like hop back and forth between the in-browser editor, or you can download a VS Code extension that will make it a lot easier to compose your apps. Like if we have, from the previous example, we had that you can see here there's like these widgets that are being loaded. The widget means it's another component. So if you use the VS Code extension, you can actually click into this and you can then see the component or like pull in the component so you know what it is that you're going to be interacting with. Yeah, and then if you go to near.org, you can actually use the search functionality here and find a few different components. So we can look for Aave, for instance. The Wi-Fi is going to cooperate. I think this is the one. I can see this. Yes. Okay. This is for Aave on the Polygon ZK EVM testnet. Where did my browser go? Here we go. While that's loading, we can, oh, there we go. So you can see this is like an Aave component that someone in the community built. We can then go to develop and check out the details, which will show us like who deployed it. It'll show us like all of the source code, and then go ahead and fork it. And maybe in this case, we'll want to like change the network that like, maybe we don't want it to point to Aave on Polygon ZKVM. Maybe we want to, sorry guys, I can't see it on my screen here, but we can change it to point to like Aave on Polygon or Aave on Ethereum or whichever network it's deployed on. And then we can do the same thing and save it. Oh, here it's over here. Or we can save this version of it locally. This will be saved in the browser, so you can just kind of like edit while you're testing. And then if you want to publish it, then you can do the transaction. So in this case, I'm actually just forking it. Live demos. All right, let me just pull up the slideshow again. Cool. There we go. All right, so just diving into some more of the technical details and showing you what we're doing here. So a lot of this, right now, this assumes a React dependency out of the box. We're launching a version of the virtual machine that will not make that assumption, because I'm sure plenty of you want to use other JavaScript packages. So right now we use props and state, if you're familiar with how React works. So like props, you can pass between components. You can also pass state, but state can, in this case, will be more global, which means that you can just like store state between components. So here's an example of how you can use ethers. So we inject ethers just by default right now to make it easy for developers to get started. So you can see here, this is like basically doing a get balance function from ethers, pretty simple to similar to what you've been doing before. And then the result here will do a state update. And then similar to like updating any sort of state in a component, it like uses the life cycle of React, and this component will re-render with the state balance to whatever the user's balance is. So that's an example of just like how state and props are going to work. Similar kind of thing here. I think this one's actually doing, the kind of smart contract call. So you can see like, it puts you can assume here that we have like the Lido contract in there, and then like encodes the data using like the standard that Ethers is expecting, in this case like balance of, and we'll call it, and then it will then update the interface based on like the result of that transaction. And then a very important part for everyone who's building a front end, you're going to want to style this component. So by default, we actually enable, this is an example of that composability we were talking about, where you can have this kind of like other component pass the props to it. It shows an example of basically how to do that. And then finally, we have styling. So we, by default, it'll let you use styled components. So it should be like a nice and familiar way for you to include your style sheet. So you don't actually have to like pull in an external style sheet. You can just build it into the component, like similar like you would do in a lot of typical React components. And that is what I have for you today. So we do have some bounties here. So we have 10K total in bounties. I think it's split up between a first place prize of 3K, 2 second place prizes of $2,000, and then 2 or 3 of 1K. If you scan the QR code there, you can check it out. And you can also come visit us at the Near booth. We're on this side. There's also like Filecoin in the graph right over there. We're right between them if you have any questions, and we'll be here all weekend. And we still have a good amount of time left, so I'm happy to answer any questions that anybody has about how this works. All right. Yeah, great question. So I guess like our goal here is that you can fully decentralize this, right? So there's a few different layers if you want to decentralize a blockchain application, right? Like there's going to be the front end code and where that's going to be running. There's going to be the smart contracts. Those parts are almost like the easy part. The harder part is like, well, making sure that like if you need radical decentralization, like I'm in a place where like there is serious censorship, then you're also going to probably need to run your own RPC. And most applications these days have some kind of data layer. Hopefully it's the graph, which fortunately is getting very decentralized, but a lot of times it isn't. And if it's not, like, yeah, you need some easy way to access that data. So like that's been a general big problem on most blockchains. Like at Near, we've worked with a lot of teams and created a lot of solutions to kind of make like just more easily indexable or accessible data available to developers. But we basically want front ends at some point to like let users kind of define their data layer, define their RPC, define their wallet, and like define each of the different parts of the stack. So I mean, yeah, that part is tough. Like right now, basically the gateway is usually just choosing like an RPC provider. They're choosing the data provider and making sure that like developers can essentially be agnostic to the choices that the gateway providers might eventually make is a bit of like an experience problem. So that's one of the ones. Oh, you mean like if millions of people are accessing, like how many? Yeah, so that's actually gets into that first question is like it sort of depends on which part of the stack will end up getting like essentially DDoS. Like it's I mean the Near blockchain itself can handle quite a few transactions, and these are mostly view calls, so they're not actually going to be updating state for users who are accessing it, which means that it really comes down to RPC load. So like we have a few applications not actually related to BOS that send a lot of transactions to the network. And so like there are some pretty battle tested RPC solutions. So like that probably is going to do okay. But depending on which one the gateway, like whoever's running the gateway chooses, that might fail, right? That's a common one we see in blockchains that get kind of a lot of load as RPC fails. So like that could be a problem. The data layer in theory could be another problem. Like if the app you're rendering, the component you're rendering is making some assumption, maybe like the developer has like, oh, we didn't want to use the graph, so we just built our own API and it's running on some like really small EC2 instance, like that could then fail. Or just like the gateway itself, if it's like, again, running on a small EC2 instance or something. So it depends. There are ways to do it. Like Near.org, for instance, like you could it can handle a lot of simultaneous users, but it's because like, you know, they built it in a way to anticipate that because they get a lot of load already. There's like, you know, quite a few people visit that page on a monthly basis. But yeah, smaller instances of each of those like could lead to some failures. But it is possible to build these things in a very resilient way these days. Maybe not like tens of millions of concurrent users, but definitely like pretty substantial numbers, especially for this industry right now. Oh, I see. Yeah, I mean yeah, this is definitely designed more for like kind of like it doesn't be static, but like pages where like the dynamic loading is data. I mean, you could use a different like it is just the front end code, right? It's just JavaScript. Like you could like stream content too. Maybe you're even streaming it from Filecoin or something. Like yeah, that would work fine. This isn't basically you shouldn't be using Near to store videos, for instance, or something that would need to be streamed, even photos. Near is kind of like a sweet spot where because it's a sharded system, like we can handle a higher state load than most chains can, but it's not designed for like petabytes of data like Filecoin is, right? Like a great solution for that would be like combining Filecoin to actually store the video using their new CDN solution to kind of like stream it, and then like piecing it together and creating the UI can be done on using BOS. That would be like my recommendation for that stack.
Yeah. So on that, what is the cost effectiveness of storing that? Is it on here?
Yeah, so it's like one near per either 100 kilobytes or megabyte. No, maybe it's a megabyte. So it tends to be like pretty cheap for front ends. Like most front ends that I deploy, and a lot of times, like after you deploy the first version, when you do updates, it's just uploading the state diff. So it ends up being like usually a few cents for most front ends. For something really rich, if you store the images and just stuff like that, it could get a little crazy. But yeah, I would recommend using other solutions for like that media, and then just using this for like the front end code. Like it is like mission critical stuff, right? Like you want people anywhere to be able to access it. Like have those pieces there, and then like the nicer like images and stuff like that can come from elsewhere. Yeah, it's a good question. So, I mean, the biggest thing is like, yeah, obviously, our approach to scaling is like adding more shards. We don't know how many shards we can add. I think right now they're testing with 100, and that's working pretty well. And we don't need that many yet. Going beyond there, it probably there's some kind of like there are going to be some sort of limits that are hit eventually. But I think we've got like the reason that we chose sharding and took on all of the complexity that comes with that is that we believed it was a much more future-proof solution than a lot of the choices that are made. So we're confident we can scale for a while. And I mean, the other thing that happens, like the price of near were to go up, just like if the price of ETH goes up, that can like manipulate the storage prices in a weird way. So what we do there is like similar to Ethereum, is like you just update kind of some of the like assumptions that are made, so that like the real cost can either stay static or go down, even like whether, and that could go the other way too, like whether the price of near goes up or down, we can kind of adjust the static costs. That is a great question. So the long-term answer will be absolutely. The short-term answer today is unfortunately, yeah, you're gonna have to use the packages that we have sort of pre-installed, and that's just because of the security assumptions of the VM. But that is a common request, and it's like one of our top priorities is to enable that. So yeah. Yeah, we don't actually. The problem we have now is it's like we have to kind of like add them manually, and so we get a lot of requests, and we don't actually have to make that choice for developers. So we are, I think, pretty close to the V2 of the VM that will allow you to import probably most JavaScript packages, or at least it will be like way more like the choice of the developer rather than the choice of us. So yes, soon you will be able to use Tailwind. Today you're gonna have to use style components, unfortunately. That is a great question. I don't have a great answer. I would say, yeah, style components, ethers JS, you can assume. I would look at a few examples. Definitely check out, yeah, like Aave, Lido, Uniswap, like some of those, just to kind of see some of the common patterns. We'll give you an idea. We should have a list, though. We'll get on in making that. All right. Thanks, everyone.